Hello everyone, it's 1 p.m. Eastern, and that means it's time to begin another of our monthly CoCoRaHS Weather Talk webinars. Thanks for joining us today. I'm your host, Henry Regis, and along with me is my co-host, Colorado State climatologist Nolan Duskin. Running our program behind the scenes today are Zach Schwalbe and Noah Newman. We're coming to you live from the Colorado Climate Center here at Colorado State University in sunny Fort Collins, Colorado. Today's webinar focuses on the Northern Lights. For those of you who are unable to join us for the live broadcast, we'll be recording it for future viewing on our website. All of our Weather Talk webinars are sponsored by grants from NOAA's Office of Education and the National Science Foundation. We're excited to have with us today an old friend of CoCoRaHS, none other than our Multnomah County coordinator out there in Oregon, Jan Curtis. Jan has had an interest in the Aurora Borealis since he was a boy. He's had a wonderful opportunity to observe the Aurora firsthand on almost a nightly basis during his time at the Alaska Climate Research Center in Fairbanks, Alaska. Jan has served as the Wyoming State climatologist and is currently an applied climatologist and meteorologist at the National Water and Climate Center in Portland, Oregon. Welcome, Jan. We're glad to have you as part of our webinar today.
And Jan, glad to have you. This is Nolan. Any rain out there in Oregon yet this fall?
Well, the rain started recently. However, I'm broadcasting from Santa Fe, New Mexico, and it's quite sunny down here as well.
Very good.
Okay, Jan, we'll take it away. And we'll join Jan with questions at the end of his presentation. We'll have some quiz stuff thrown in the middle.
Well, thank you very much for allowing me the opportunity to give this presentation. It's obviously one of my favorite subjects, if not my most favorite subject to talk about. And I've had probably over 1,000 hours of observing the Northern Lights in Alaska from 1995 to 2001. It all started in 1959, a long time ago. My great uncle moved from New York to be one of the founders of the state in Alaska. And every couple of years he'd come back to meet the family and talk about the adventures in Alaska. And one of the things as a kid I just constantly remember over and over again is his talks about this magic thing called the Northern Lights. When he went hunting in the fall, he said it was light enough to read a newspaper in the middle of the night. That's how bright the Northern Lights were. And he also indicated that he actually could hear them. And that to me was just too fascinating to pass up the opportunity to see him for myself. So when I retired from the Navy in 1995, I moved up there. And I was only going to stay for a year and wound up landing a job at the university. And I was very fortunate enough to meet the eminent Aurora scientist, Shin Akasufu. And we collaborated on a number of projects, including a book that we both were involved with, and I'll talk a little bit about that later. Well, to start the, see if I can get my, there it goes.
Jan, this is Henry. A couple of folks has asked if you could speak just a little louder. I'm getting some questions here.
Okay, sure.
Thanks.
To start the session off, I think it would be very interesting to see if people can answer some basic questions. And the first one is, can you see the Northern Lights from Australia? So Noah, you can poll the group and see what the answers are.
Great. So this is an opportunity for you to select either true or false for this. We're going to give it about 10 to 15 seconds here. Let everyone go ahead and submit their best guess. And I'm going to go ahead and close the poll here in about 5 seconds, and then I will display the results for how everyone answered. And it looks like 81% of you are saying false.
Well, that's good that you did that, because the answer is, it's kind of a trick question. While we have Northern Lights in the southern hemisphere, there's a thing called Australis Borealis, which are called the Southern Lights, and they're seen south of the equator. So that's the reason why the answer is false. Just last year, from New Mexico, I was able to record the Northern Lights, and as you can see in the picture, it was pretty obvious and quite remarkable to be seen this far south in latitude. Further away from the northern latitudes you get towards the equator, the rarer the events do occur. Now for the second question, okay, what is the most common color of the northern lights? And your choices are red, green, blue, or none of the above.
Okay, I'm going to go ahead and display the next poll here, and here we go. You should all have a choice between red, green, blue, or none of the above. See, lots of people submitting their answers. We're going to give it about 10 to 15 more seconds. Okay, I'm going to go ahead and close it now and display the answers for everyone to see. So it looks like 59% said green and 20% said red. Jan, go ahead, and I'm going to go ahead and hide these results now, and we can see what the answer is.
The answer is actually depends on where you're located, but for the most part, if you're in the northern latitudes, green is the predominant color, and I'll explain how and why that occurs. However, if you live in the lower latitudes, like in New Mexico, red is the color that you see, and it's because you're looking north and you're actually seeing the very tops of the northern lights, which have a tendency to be red. So that's the explanation. Now, out of curiosity and a little bit of fun, I thought it'd be interesting to do a Google search on the northern lights, Aurora Borealis, and southern lights. And as you can see, very interestingly enough, there's a lot of interest in the northern lights, both commercially and scientifically. And it was quite fascinating that nearly 1/3 of a billion references on the internet referred to the aurora. And obviously, most people have not seen the northern lights or weren't aware of seeing them when they looked up at the night sky. But yet, our society is replete with curiosity and the allure that's associated with the northern lights. This was the book that I helped with Dr. Shinaka Sufu, and that was kind of an exciting highlight in my professional career, an amateur photographer. And this is actually still available on Amazon.com. It's updated routinely. And fortunately, Dr. Akasufu is in his mid-80s now and still doing quite well. And I'm in contact with him on a periodic basis. However, before that, I was very fortunate enough to get a lot of national visibility by having my photographs on front covers of two fairly important periodic magazines. Both of them, as you can see here, and maybe I'm getting a little bit more fame by doing this CoCoRaHS presentation. But in the history of civilization, the aurora has been heralded or discussed probably over the last 4,000 years in one way or another. And a lot of times there were periods when the northern lights are not visible, and they take a documented interest, such as where I highlighted those dates in red. When the solar activity decreases, and that's where northern lights originate from, the visibility of the northern lights becomes practically nil. And strangely enough, history also shows that Aurora is known to be associated with bad events, such as the assassination of Julius Caesar. But maybe that's just a coincidence. But yet, because it was something that was not known until the last century, things that occur in nature are sometimes looked at as something that's scary, and perhaps that's where the omens come from. Now, where aurora comes from is actually from the sun. We have these what's known as coronal mass ejections, CMEs, and they put particles in the into space that are directed towards the Earth. And in this little clip I wanted to walk you through is that these particles come off the sun periodically, and they're associated a number of times with solar sunspots. Particles that come off the sun travel between 2 and 4 million miles an hour. And when they hit the Earth's magnetosphere, as represented by these bands in this pictorial, they eventually cause the northern and southern bands to combine. And as you'll see in a second, we get basically a flashback of all that energy and particles into the Earth's magnetic fields. And in both the northern and southern hemispheres, we get what's known as the Aurora oval. It's kind of a ring of fire where the predominance of the displays are indicated. And I'll talk a little bit more about that as we go along. Here's a satellite view from outer space showing what the Aurora oval will look like as the Earth is spinning and it undergoes modifications. As you note, that most of the activity is staying very far north, and it's only the northern latitudes that generally see this type of events. The Defense Meteorological Satellite Program, which is an Air Force weather satellite, has the ability to take photographs at night. Well, you're not going to see clouds at night in visual light, but you can certainly see city lights, as noted by those yellow spots across southern or northern Europe. But if you look at the far north, you see these wispy bands of yellow, and that's actually the northern lights in progress. And they are visible from space through the means of visual satellites. Now here's an interesting clip. This only lasts for about a minute, but it represents about a 23-minute flyover by the International Space Station. And what they are flying over and into is the northern lights as viewed from space. So you're seeing this in basically 3 or 4 dimensions at the same time. And you can see that not only are there different forms associated with the northern lights, at the very tops you can see are red, and lower down you can see the structure, fine structures associated with it, lighting the clouds and the oceans below. This final sequence here, you see that green glow on the horizon. That's the air glow, and it's a very common phenomena that occurs all the time over the Earth's atmosphere because of the interaction between the various molecules and the solar activity. And it's visible any latitude on Earth from the equator to the pole. Now, with respect to the northern lights, we saw the Aurora oval that circles the globe, the northern hemisphere and southern hemisphere. But they're also dimensional in height. They run anywhere from 60 miles up to 300 miles up. And the higher up you go, the colors change from generally this pinkish purple color at the bottom to green to red. And there's reasons for that. Now, what you're looking at is a broad view of the northern lights. But if you look at it in looking directly straight up, the northern lights is only about 60 feet thick. But extending up 300 miles makes them look very massive in size. Why the colors we have? Well, it depends on what interaction the high-speed particles from the sun interact with the Earth's atmosphere. We have reds at the lower atmosphere and at the very tops of the atmosphere caused by oxygen atom. And as everybody knows, most of the oxygen that's in the atmosphere is a molecular type, is O2. And that's the color green that we see in the northern lights. And when we get a mixture of some nitrogen in there too, we can kind of see blues. And a lot of times all these colors will intermingle with each other, and you don't get a pure red, green, or blue, but you get a mixture of the different colors. Now, forecasting the northern lights, NOAA has a forecasting site that people can look at in real time. The way they operate is they have actually satellites in space that measure the solar winds as they transit past the satellite. Now, why is northern lights important? Well, they do have impacts on different user groups out there, from navigation to people who use even ham radio operators or radio signals. They affect the power grids on Earth. And obviously, satellites that fly through them, they're interacting with a lot of electrical and magnetic fields that can ruin or destroy the circuitry that's on board. And we'll talk a little bit more about specifics on how these things occur. One of the sites that I go to almost every day, and you can subscribe for a free email alert to any possible northern lights, is spaceweather.com. Not only do they talk about the sun and the aurora, but other astronomical events such as this weekend's meteor shower that's going to occur. So I highly recommend, if you're interested in knowing when to go outside and look for the northern lights and be advised in advance, to use this service. And again, it's free and it's great. Now, northern lights comes in different forms, and we'll walk through some of the photographs that I've taken over the years to kind of illustrate this. But you basically got a very smooth, lamellar type of flow look to it. And then you get what's known as ripple bands, that arrays that form within them. And they can form to a point where they actually look like a curtain waving in the wind. And at the end of this presentation, I'll actually show you a live movie that was taken in real time that shows how dynamic the northern lights really are. Now, depending on where you're located, it's going to look different. Even though it's the same northern lights, it's a perspective type of thing. And if you're directly underneath the northern lights and looking straight up, remember it's only 60 feet thick, but if you're looking up through 200 miles worth of this electrical field and lighting, you're going to see some pretty spectacular northern lights. And usually that's only available, or one can only see it in places like Alaska and Scandinavian countries. You have to be closer to where the maximum extent of the northern lights occurs to be able to see a phenomenon like that. It's referred to as the corona, and I have some real pretty photographs of it, and I'll show you in a minute. However, if you stand further back from the point of origin for the northern lights, they take on all these different shapes and forms. And over the course of the night, this will change, and I'll walk you through the steps of how these things change. Now, in 1964, it was determined and discovered that basically aurora forms in what's known as substorms. Any night up in Alaska, you can go out if there's no clouds and see the northern lights, but a lot of times they'll just be very quiet in the sense where they're just a patch of light or a little band. They don't do anything. They sit there the whole night. While it's kind of interesting, it's kind of boring. But when it gets into the substorm phases, the growth, expansion, and recovery phase, that's when really things get very interesting. Now, in the growth phase, we have the onset of the energy reaching the Earth from the sun. And what's very important is that not all CMEs, the coronal mass ejections that reach the Earth, will cause the northern lights to occur. Because we're dealing with a situation where we have north and south poles, which indicate charge, as well as magnetic fields, you have to have the particles coming to the Earth be the opposite pole of the incoming energy and particles. So what they have this thing called the IMF, which is the interplanetary magnetic field, and if it's pointing southward, the North Pole will be attracted to the incoming particles, and that creates the northern lights. If it comes in as a northward tilt, or deflection as they call it, then because the North Pole is the north and the positive particles coming in are north-oriented, they repel each other, just like a magnet's interaction with another magnet would do. The most exciting part is the expansion part, is when all the energy is released, and it usually lasts only from 30 minutes to maybe up to 2 hours. And this is the really exciting time. In fact, it gets so bright that when I've been in the wilderness observing the northern lights, it does something to animal life, and the wolves will actually respond to the glowing brightness and start howling. And you know, it could be 50 degrees below zero, and I'm dressed in my goose down parka, and it's quite comfortable. But when you hear these wolves howling at the northern lights, and you see the snow turn green and shimmering in the shadows of the trees, that's where you really get the chills. And that's the thing that attracts people. Once you see the northern lights, you want to come back and see them over and over again. It's just a very spiritual and almost unreal situation to experience. And I wholly encourage anybody who can go up to Alaska or northern latitudes to see them, to be a part of that experience. It's just something else. At the end of this really massive display, there's a period of about an hour or so where we get what's known as pulsating northern lights, or black aurora. And black aurora is kind of interesting because you have the entire sky in this glow, kind of diffuse glow, and yet you see patches of blackness where the northern lights cannot form. And in that in itself is a very interesting phenomenon to see. The good news about these phases is that they can repeat 2 or 3 times in the course of the night. So usually about midnight is when you get the maximum northern lights, but then they can reoccur at 2 o'clock in the morning and 4 o'clock in the morning as well. It all depends on how active the sun is and the orientation of the Earth's magnetic fields. So, for example, this is photographs I took of the quiet phase before we get into the substorms. Usually in the course of night, about 9 or 10 o'clock at night, I would go outside, and this is from Alaska, look east, and start seeing these arcs forming and getting higher and higher in the sky. And as the evening progresses and we get to about 11 o'clock, we get what's known as these bands. So homogeneous bands, meaning that they're pretty lacking detail, but yet they're showing a lot more activity over the arcs. And then we get into the actual expansion phase, which is where the excitement occurs. And you get individual rays that are moving quite rapidly across the sky. It can go from one horizon to the other in a matter of seconds. And sometimes the bands will form into curtains with all these rays occurring. And the next phase is you get these beautiful curtain-shaped formations. Some of them are structured, some of them aren't. And they actually seem like they're waving in the wind. They fluctuate so quickly that it's actually very difficult to photograph the northern lights because you usually have to do an exposure of several seconds. And in that time period, the object, northern lights, are moving, so you wind up getting a very blurred image. But when they stay still for an instant and you can take that time exposure, then you get these types of photographs. My favorite formation is at the end of this expansion phase called the corona. And you're looking essentially straight up and you're seeing the convergence of all the northern lights to a single point in the sky. It's akin to looking down a railroad track and seeing the vanishing point in the distance as the two rails get closer and closer together. But what I really like about this formation is if you notice some of them, they kind of suggest maybe there's an angel involving or there's some kind of winged creature out there that's kind of interesting. But what's really pretty about this is that although they only last for a couple of seconds, these formations, they are extremely colorful. You get all sorts of energetic activity going on. So that's kind of the end of the expansion phase. And then we go into this quiet phase where you get these glows. Sometimes they're colorful, sometimes they're not. But they just hang around for a while until the next surge from the sun recharges the upper atmosphere. And here are some more examples of this glow. These exposures are maybe 30 or 40 seconds long, so actually while it is glowing, it isn't as bright as those discrete forms that you saw just recently in the previous slides. Now, as I showed you earlier, the northern lights have basically 3 colors associated with them. At the very bottom of these displays, you can see a little bit of tinge of red, and that's the oxygen or the oxygen atom being excited. And that's about 60 miles above the Earth's atmosphere. The northern lights really can't go any further at lower elevations. However, if you look at these pictures, it sure looks like the northern lights are hitting the horizon. But what you're actually seeing is the Aurora oval in the distance where you're actually seeing the northern lights below the horizon. So it meets up with the ground and kind of makes you think that it's a lot closer than it really is. But that distant shot of the horizon, you're looking at 300 or 400 miles away to give you a perspective. Now, a lot of times the very tops of the northern lights, instead of being red, will have this purplish color, and that's actually the sun that's way below the horizon, actually reaching the very tops of the northern lights, which are about 300 miles or so above the Earth's surface. And these effects, although kind of difficult to see with the naked eye, the nature of photography and film and the digital technology, the colors come out really vivid. Now here's a very interesting story. I think it's probably my favorite one. These pictures were taken within 30 seconds of each other. When I lived in Fairbanks, I lived about 2 miles west of the university in pretty dark skies, but I was in a rural area where I did a lot of my photography on this dirt road. And I also lived in an area where there was water delivery into holding tanks. We didn't have wells in this location. So in the middle of the night, I'm out there photographing in the middle of the road, and the water truck, for one reason or another, was doing deliveries really late. And the truck driver saw the northern lights as I did and decided to go down the road maybe 5 miles an hour and turned off his lights and stuck his head out the window looking at the northern lights. At the very last second, that very last picture on the right, I snapped the picture, and he immediately turned on his headlights and stepped on his brakes and missed me by about 2 feet. He apologized, and I was kind of stupid to be in the road, preoccupied looking at the northern lights. But that photograph actually got into National Geographic's in the November 2001 issue as a double-page entry, and I was lucky enough to get a monetary compensation of $12,000 for that photograph. So that kind of paid for my hobby right there and then with photographic equipment and the like. Well, I've taken about 1,000 of my photographs that I've taken over the years, my best ones, and put them into slideshows set to different types of music. And as you see in the listing below, feel free to access them later, and you'll hopefully enjoy seeing the different aspects of the northern lights as I've seen them.
And Jan, we're going to list those URLs on our website for folks that they can click on those.
Very good. I've always been asked where to see the northern lights, the best places to see them, and I was in Fairbanks for 6 years or so, and I'd say certainly Fairbanks had a fair share of seeing them. In fact, I think they tallied about 243 nights a year. If it's clear, you can see the northern lights. The problem is that in the fall and winter months, it's quite cloudy there. For example, in January, the average cloud cover is 61%. In November, it's even higher at 65%. In fact, most of the northern latitudes, fall is not a good time to see the northern lights because there's just too many clouds. The favorite time that I like going there, and I'm hoping to go back there as a revisit this coming March, is in March in Fairbanks, and you can see why, is that the cloud cover falls to less than half the time. In fact, a third of the nights are even clear, or there's just a few clouds. So almost 50% of the time in March, you're guaranteed to see pretty good displays. The frequency of the northern lights varies depending on what latitude you're at, and it all depends not on where the North Pole is, but where the magnetic North Pole is, and that happens to be in Baffin Bay in northern Canada. And because of the fact that the North Pole, the magnetic North Pole, is in the Western Hemisphere over North America, or closer to North America, and not over the Eastern Hemisphere, we actually get to see northern lights much further south than they do over, let's say, in Russia. So geographically, we're in a very favorable position. But even more than that, people that live in the Midwest can actually see the northern lights better than if people live, let's say, where I do in Portland, because they are geographically closer magnetically to where the North Pole is, magnetic North Pole. And northern lights follows the cycle of the sunspots on the sun that occur approximately every 11 years. The higher the sunspot number, the more active the sun is, and therefore the more likelihood to see northern lights. There are periods when the sunspots and activity decrease, and even in the northern latitudes, they become much less frequently occurring. But overall, we're in a phase now where we're hitting solar maximum, and over the next 2 or 3 years, places like Fairbanks, in the springtime especially, will be ideal to watch the northern lights. And here's an example of different types of storms that occur, the intensity. When you get what's known as the KP index, readings that are higher in number, the northern lights are visible much further south. Normally anything above 5 can be viewed in the lower 48s in the northern tier states. By the time we get to 9, which occurs not so frequently, but when they do occur, they are actually visible even in Florida. So that's why subscribing to spaceweather.com, they can give you an indication of what the intensity of the northern lights are, and you can plan accordingly to see it. Well, I get a lot of questions as to how to photograph the northern lights. And in the old days, I used to use film. I haven't really gotten involved in photographing the northern lights with the digital camera, but the principles are basically the same. You need a wide-angle lens to cover a lot of sky. You need to have a tripod because you're taking a time exposure. And because of the coldness associated with being in a high latitude, it's very important to have hand warmers that you can either keep your camera warm with, or your hands for that matter, and extra batteries because the cold will zap your batteries quite fast. The best lens setting on your camera is to open it up as wide as you can to gather as much light in, but then stop it down a little bit for those photographer people out there. And the idea is that you want to have the most light coming in, but of the best quality, and so that's why you stop it down. And the speed depends on the brightness and movement of the northern lights. I used to shoot in 400 to 800, but with these digital cameras and technology, I think you can get away with shooting at a slower ISO. And the advantage is the slower the ISO, the less graininess your image will look. Also, your exposures can run anywhere from a second to 10 seconds. And then the trick is, do you use Photoshop to make them look really good, or do you want to keep them the way it kind of appear to your eye? And what I have is some examples of using Photoshop as compared to what the camera picked up or what the eye picked up. And looking through these images, you can see some of them are brighter and greener than others. And the little asterisks are actually the ones that are not exaggerated or not put into Photoshop. And you can see that you can create an assortment of different kind of feels and looks to these images, but if you want to be honest and show what you're actually seeing, basically what the camera produces is what you really should go with. Here's some more examples. The bottom one obviously is really pretty in that real green color on the right, but the realistic colors are more what you see with the left. Now, northern lights actually can create problems, and there was the biggest northern light storm that ever occurred in 1859, and in those days they had telegraphs, and the northern lights induced an electric field in the cables that ran between the operators, and caused a lot of problems for those people that were operating the telegraph because they caught on fire. Some of them actually disconnected from the power source, and there was just so much residual power that they were still able to communicate. And that was the first indication that maybe northern lights are more serious than just something pretty to look at. Well, let's go 100 years later, and we had a really major display that was visible all the way down to Cuba, actually, on March 13th, 1989. And caused the Canadians from Montreal and the eastern provinces to lose power because of the surge of induced electrical fields that occurred in power plants. And this was one that was a very interesting study that was done that showed that technology is great, but the force of nature can certainly make a real big difference on survivability and functionality of things. We also know that with GPS now, the northern lights can disrupt the positioning accuracy, and any satellites that are orbiting will move through the northern lights if they're in polar orbits and affect the electronics that are on board. So they do have a problem that they have to be concerned with, and communication is the way the world operates now. So any disruption to communications and power, for that matter, really can create problems for us down here. How often these threats occur depends on the intensity of the solar activity. The higher the level, from M class to X class to X plus class, falls off exponentially. From X class, that's an intensity of 10, to X plus class, intensity of 100, you can see that the occurrences fall off with them. But the fact is that when we get into X-class flares that impact the Earth, this is when activities have to be on alert to be concerned about the surging electricity that might be induced by this. Northern lights are not only found on Earth, but through the Hubble telescope, we've actually been able to observe and photograph them on some of our other planets like Jupiter and Saturn. Now, my uncle, as I mentioned earlier, heard the Northern Lights, but there has never really been any documentation as to what they're actually hearing. If you think about it, the Northern Lights are occurring in the vacuum of space. So as a result, sound can't travel through space. So what are these people hearing? Well, recently, this past summer, some scientists in Finland set up some sensors, and they actually heard what sounds equivalent to, and I'll do it, a clapping sound. Well, I don't know what would have caused that, but they did record it, and my uncle used to talk about it sounding like a crackling sound or hissing sound. And I actually met a number of scientists that worked up in Alaska years and years ago that have heard it as well and mentioned that. And having spent at least 1,000 hours observing the Northern Lights, I'm afraid to say I've never actually heard them. Although in my mind, I can actually think of them as making sound. But the question is it really something that's being induced by the Northern Lights or some kind of image? You ever watch the fireworks going off and in the distance? Before you actually hear the sound, you can actually hear the fireworks. Well, I'm thinking maybe that's the same thing with the Northern Lights. They actually kind of induce a kind of an imaginary sound. But who knows? I don't know. Okay, we have another question coming up, and it should be fairly straightforward. Are the Northern Lights a hazard to be reckoned with? True or false?
All right, this is Noah again, and I'm going to launch the quiz. True or false? You are not being graded. We'll give everyone about 10 more seconds here to post their guess. Great. I'm going to go ahead and close the poll at this point and now share it for everyone to see. 87% report true, 13% report false.
Okay. Well, we know that it does impact communications, navigation, and the power grid. And while it may not affect you directly, it does affect a number of people throughout the world on any given day. Okay, here's another question. What is the lowest altitude of the Northern Lights?
Okay, I'm going to launch the poll. Is it 300 miles, 150 miles, 60 miles, or does it reach the ground? I'm going to give everyone about another 10 seconds here. Great. I'm going to go ahead and close the poll and share it with everyone. Sorry, my phone started ringing in the background.
Do we have a result?
Yeah, Jan, I tried to share it here. I've got it up on, hopefully up on the screen. You might not be seeing it, but 75% of the attendees guessed 60 miles.
And the answer is 60 miles. That is correct. And for our final question, what's the best time of year to see the Northern Lights? Winter, spring, summer, or fall?
Okay, I'm going to go ahead and launch this quiz. Winter, spring, summer, or fall? Give everyone about 10 more seconds. Okay, great. I'm going to close the poll and share the results. We've got 52% of the people saying spring, and then 29% said winter, 10% said fall, and 9% said summer.
Well, okay. Well, the answer is the equinox. March is probably the best month because of the clear weather. What's interesting is you can't see the Northern Lights in the summertime because you have basically light conditions due to the midnight sun. the sun has to go below the horizon of about 12 degrees before you can actually start seeing the northern lights. So there's a period of time, even in Fairbanks, Alaska, from middle to late April through the end of August, where the skies are just too light to see the northern lights. Now these I'll answer, and we'll go through it a little bit. Which location experiences the most frequent occurrences of the northern lights? And the answer actually is Alaska. The North Pole is further away from the magnetic pole than the North Pole is itself, because of the geometry. And the further south you go, the less the frequency occurs. Next question is, how fast do the northern lights travel across the sky? And the answer is, what makes the northern lights phenomena appealing to view is that they occur differently all the time. So the answer is all of the above. You have all different types of dynamics which each display, and that's what makes it really fascinating to observe. Next question is, can the northern lights be heard? Well, let's say maybe, but from space itself they can't be heard. They can possibly be inducing some static charges if conditions are right, and maybe that's what people are hearing. And are the northern lights bright enough to cast shadows? And the answer is most definitely. I won't say it gets as bright as a full moon, but it gets pretty close to that. And these are the answers. And the one I like is the fact that when the snow turns green, the wolves start howling. And now, how do you photograph the northern lights? Well, you have the still camera that can take the shots that I've taken. But if you want to spend a lot of money, there is a camera out there that can actually take real-time movies of the northern lights. And since we're a little bit ahead of schedule, I'm going to display that particular movie for people. And bear with me as I go to the clip here. This was taken this winter from Norway, and I'll blow up the screen so you can see it better. And I'll take off the sound. It comes with a musical soundtrack, which is kind of pretty, that goes along with it. But what you'll see now is live, real-time imaging of the northern lights. And in some scenes, you'll actually see people moving around to show that this is not trick photography. The very bottom of the northern lights seen in this depiction here are those reddish colors with the lowest elevation of the northern lights down to about 60 miles. And you can see curtains forming and rays racing across the sky. And believe it or not, this is actually very difficult to photograph as a still picture, but the ability to see the motion in this is quite amazing. Now here you see some people looking up at the northern lights, and as the camera pans directly overhead, you'll see how the dynamics of looking directly up into the northern lights and forming all these beautiful dancing motions takes place. And as you can see, what you're looking at is basically a 60-foot wide image, but extending up 200 to 300 miles in scope. And so that's why it gets to be so bright and colorful. The little bright image, there are stars. Some of them are being picked up. The northern lights usually, no matter how bright they are, you can see stars through them, and that's how you know that it's not a cloud or something unusual. And here's a picture of, again, a different perspective of a curtain and the various bands and rays that are associated with it. In fact, right now we're looking at the Orion constellation with the belt stars that are occurring in this area. That's looking south. So even up in the northern latitudes, the northern lights can actually be on the southern horizon and look south. So as this is running, I'm open to any comments or questions that people might have, and I'll leave it to Noah and the group to get the questions.
Wow, Jan, this is amazing. You've triggered a lot of memories for me. I think I was a witness in 1989 here from Colorado. I think there's been 2 times in my 35 years that I've, from a mid-latitude position, been able to see northern lights south of our position. And is that one of the possible ones, that 1989 episode?
Yes, in fact, I was living in Colorado at the time, in Monument, Colorado, and remember looking outside at the display, and it was south, and it was very red in color, which at the time I wasn't really aware of why it was so red. But that display was just phenomenal, and what you did see was that particular display, no doubt.
Well, Jan, thank you for a very informative presentation there, and some really exciting stuff. We're going to open up the time for questions now. We've got a couple have come in already, and let's. A gentleman from Michigan, Justin, asked about the camera, the best camera to use. Now, you showed a video camera. Is there a still camera that you recommend?
Well, there's still film cameras out there. However, the technology is such that buying a relatively inexpensive digital camera is the way to go. I happen to have a Nikon camera that runs about $1,200. That's more the higher end types. You want to have a digital camera that can take time exposures up to 30 seconds or more, and you want to have it so that you can shoot at a faster speed. Usually 400 is the maximum speed on more of the inexpensive cameras. However, with the cheaper cameras, you get more graininess in the long exposures. So the more money you pay, the more you can get better images, is the bottom line. But almost any digital camera these days should be able to provide you an opportunity to take pictures of the northern lights. And in fact, the one that you saw at the beginning that I took in New Mexico with the red sky was taken with a $300 digital camera. And so you can do quite well with that.
Okay, we've got another question here, and you had mentioned this a little bit before. Their question is, what is the effect upon propagation of waves for amateur radio operators? So what goes on there?
Well, it's interesting that the Aurora actually will heat up the atmosphere, the different layers like the F layer and so forth, which are used for ham radio operators. So what happens is you get periods of enhanced abilities to communicate via high frequency, but then there'll be blackout periods where you will not be able to communicate at all. So it all depends on timing and location, but it will impact it one way or another, enhance it or degrade it considerably.
Thanks, Jan. Here's one from Rick, and you mentioned that sometimes in Alaska they're not seen every night. He wants to know if northern lights occur every night. So what's the story there?
Well, for the most part, the northern lights will occur. Yeah, most of the time the northern lights will occur every night, except in the summertime you can't see them because it's too bright with skylight. When I was in Alaska, I didn't stay up every night all night long. But there were a couple of nights, at least in Fairbanks, where the sky was completely dark, and that was really a very rare exception. But it depends what phase of the solar activity you're in. If you're in the maximum phase, which we're in now, invariably you'll see some form of the northern lights in the northern latitudes, and we're talking about between 58 north and further north than that. Southward, you're only going to see the northern lights maybe once a month. But then again, it depends on where you're located. If you're in North Dakota, you'll see them much more frequently. If you're in New Mexico, you'll see them very infrequently.
And Jan, a gentleman from Steve here mentioned about he mentions the 11-year sunspot cycle. You showed a graph. When is the next expected peak? He would like to know. So I think you showed somewhere in the next 5 years.
Well, the actual peak is expected to occur probably in the next 6 months to a year. I'll cut the sound here. 6 months to a year is supposed to be the solar maximum. What's very interesting, however, is the fact that this particular solar maximum is the weakest one that's been experienced in quite a number of years. In fact, I think it's over 100 years that this is going to be the weakest solar maximum. And remember, when I showed you that history of northern lights, there were periods back in the 1600s that there were no northern lights, or very few of them. And that's a period of time when there were no or very few solar sunspots that were visible. So the bottom line is that although we're going into solar maximum, we're not in the typical solar maximum that we've experienced over the last 3 or 4 cycles. So while there will be more northern lights visible in the coming year or two, they may not be as intense as they have been in the other solar cycles that we've experienced.
Okay, Jan, thanks. Ruta from Maine writes, and she talked about, mentions the photograph of Saturn. It looked at both poles were lit with northern lights, or northern and southern lights, I guess. Could you talk a little bit about the planets and what the 2 poles being lit are?
Yeah, just like the Earth, though, that has an iron core that helps perpetuate its magnetic field. If you've ever used iron filings on a bar magnet when you were in elementary school, and you see the fields lining up, the iron files lining up on the north and south pole, well, that's essentially the way the Earth operates. It actually operates like a big bar magnet. So when particles come in, both in the northern and southern hemispheres of all these planets that have potentially iron cores, you're going to get the same kind of effects, and that's why you get the symmetry of northern and southern lights. In fact, what's very interesting is they've actually photographed the northern and southern lights at the same time, and they were mirror images of each other when they were taken, even though they were several thousand miles apart. So the magnetic field, although you would think they're different from one hemisphere to the other, they actually work very much in unison with each other.
Thanks, Jan. Jackie writes and wants to know, how does air pollution affect the aurora?
Well, air pollution affects the aurora only in one way. When you have more air pollution, it makes the sky harder to see. The northern lights and the air pollution generally stays within the first 12 miles of the atmosphere, which is well below where the northern lights are. So if you're living in a place that's very polluted, especially with light pollution, but if we're talking about soot and things like that, it's certainly going to impede the ability to see the northern lights, but the northern lights are going to occur regardless.
Okay, here's one from Doug from New Hampshire. Wants to know, is it any time the northern lights are visible during the daytime? So is there any chance of that happening?
Well, there is actually, in a very unusual circumstance, when you're in the very northern latitudes where the sun barely gets above the horizon or just below the horizon, you can actually see the northern lights in daylight. But that's a very rare occurrence, and you have to be in a geographically very northern latitude. But as it gets brighter, the skies, it becomes less likely to see the northern lights. So the bottom line is the northern lights, while they're very bright, really can't be seen if the sun is higher than 12 degrees below the horizon.
Okay, we've got another one here. Frederick wants to know, can the aurora be heard on shortwave frequencies?
Well, they can be indirectly. There's probably the ability of what's known as fade in and fade out, where the signal, there's some bouncing. Now, I'm not a ham radio operator, but at that spaceweather.com, a lot of times when there is a pretty active northern lights display, they will actually provide little sound clips of the way the northern light sounds with respect to radio frequencies. And so the answer is yes. I can't tell you exactly what it sounds like or how it does that, but yes, it definitely will be, you can record it to some extent.
Okay, well, thank you, Jan. We've gotten a lot of great questions. Some folks also talking about when they've seen them. I'll pass those on to you during their lifetime.
I've got a couple more questions, too, if you have time.
Sure, go ahead, Nolan.
Now, you show the curtains in sort of circular patterns. Do you ever see things like that would be considered a vortex-type movement?
Well, actually, I've recorded one that looks like a little mini cyclone on occasion. Sometimes the northern lights will break off and form a little patch that has some swirling motion to it and structure. So yeah, I've actually been able to see that and record it. In fact, if I can find that particular image, I'll send it to you. I think you'll find it interesting.
Great. And you answered a question that I didn't even know to ask. Our family has visited Upper Michigan almost every year for over 25 years during the summer months, and while nights are short, it's only a totally dark sky from like 11 or a little after 11 p.m. to maybe 3:30 or 4 in the morning. But we often see northern lights, and I didn't realize that that location was particularly close, more so than most of the continental U.S., to where the northern lights core area was. So that was fascinating to see. One of the phenomena that I observed, and you probably, again, with so many hours of observing it, was interfering wave patterns, just like in a swimming pool where there'll be waves, but they'll be bouncing off of all the sides, so you end up with interfering waves. And saw just an incredible display of what looked like rapidly moving waves from multiple directions, setting up interference patterns. Is that a common phenomena?
It most certainly is, and again, that's what makes observing the northern lights so fascinating. It's just like you never know what's going to occur, but every time it occurs, it's different than the time before. So it's never boring, and the fact is that you're seeing something that very few people actually do see, and in that regard, it's a very unique experience. In 1999, I had the opportunity to be on a Discovery Channel show called The 10 Most Natural Wonders of the World. And strangely enough, the Northern Lights was considered the #1 phenomenon, which I was very happy to see. And in it, I basically was quoted by saying that looking at the Northern Lights, being very spiritual, is like looking in God's eye. And it's basically, that's the mysticism and the beauty, and I can't really explain it because it's an emotional experience that when people see it, they come back time and time again. When I was up in Alaska, people would see it the first time, and year after year they'd come back and we'd talk about the previous year and what's going on. And these people were from Florida or other places that they normally wouldn't see it. It's just a captivating, this magical phenomena that's just so easy to observe if you're in the right place, and just so mystifying at the same time.
And are there, just like there's storm chasing safaris where people who know nothing about storm chasing can pay a fee and line up with an expert, are there that sort of thing to go along with an expert to experience northern lights in the different parts of the world that experience them?
Absolutely. It's a big industry, and one group in particular, a society that takes advantage of that, are the Japanese. They really love, there's something about the Northern Lights for them that's different than anybody else. And but you can get tours to Alaska, not only places to stay, but advice on how to photograph the Northern Lights. I know there's places in Norway that offer those opportunities as well. Now, of course, the further you go, the more expensive it gets. And I've always recommended to people to go up to Fairbanks. That's probably your cheapest and easiest accessibility to go to. Rent a car. Just have to go 5 miles north of town, away from the city lights. Look north. There's nothing there except dark skies and the northern lights, and you'll be rewarded for it by doing that.
Jan, I've got a couple more questions that have come in. Someone wanted to know what the website was where they can enter their lat lines for Aurora predictions, and maybe you can, if you can't give that right now, we can list that on our webpage afterwards.
Oh, sure. The way you subscribe is basically it's spaceweather, as one word, .com. And in the presentation I gave, there's a NOAA site that talks about the probabilities and the intensities of the incoming solar storms. And all you have to do is Google NOAA space weather, and it'll give you that particular page.
It would really be great if they could run a crawl on the bottom of the TV sometime if there was an aurora. I completely missed one a couple of years ago. Didn't venture outside. Didn't find out till the next day. So yeah, that's something it would be good to have. And here's another question here, gentleman in Florida, the 1989 March 13th event. He saw it in northern Florida, and he says he was able to hear an NPR station from 300 miles away in Tampa. Is that normal? Is that would it have affected the radio like that?
Well, I would say that that's pretty unusual, and because of the occurrence of that very intense northern lights, it probably just totally caused the atmosphere to go chaotic, and that would seem very reasonable, or an explanation of why you could receive something so far away like that.
And Jan, how accurate are the space weather Northern Lights forecasts at this point for the 1- and 2-day forecast?
That's a very interesting question. Generally speaking, I would say that they're probably, again, it depends on where you're located. The further north you are, the more likelihood you're going to get something anyway. But if you're talking about living in mid-latitudes of the U.S., the frequency or accuracy falls off by a considerable amount. So, for example, for you in Fort Collins, when the warning goes out, you probably have a 20% chance of seeing it. If you're in North Dakota, that same warning, you probably have a 50-50 chance of seeing it.
Great answer. Thanks.
And someone has sent a link. The Canadian Space Agency also broadcasts when the Northern Lights will be visible too. We'll list these on our website for you folks. Also some pictures, time-lapse pictures, some other volunteers. Well, Jan, that's going to wrap it up for today. We really appreciate you coming on our Weather Talk webinar. Really fascinating stuff, and we look forward to maybe seeing some Northern Lights across the country this year. That'll be really neat.
Well, it's my pleasure, and thanks for everybody to attend this presentation, and contact me if you have any other questions.
Okay, and we'll also post this on our website, the actual presentation from today. Again, as you guys, folks, leave the survey, the webinar today, to please take the survey at the end. And we want you to join us next month for our next CoCoRaHS Weather Talk webinar. That'll be on Thursday, November 8th, 2 days after the election, and it'll feature Grant Gouge of Knoxville, Tennessee. Grant will talk about weather optics. And Grant does an excellent job, a wonderful photographer, and I'm sure that'll be a very exciting webinar. We already have that on our website on the Weather Talk page if you want to sign up for that one. And so we hope to see you there. So from Fort Collins, we wish you guys a wonderful day out there, and we'll see you next month. Thank you.